Welcome to my YouTube channel VP Gupta Classes. Now I will discussing about the topics which is called potential energy of an electric dipole in an external field. It had already discussed in previous lectures, and I will also discuss about these topics. In previous lectures, I had derived the expression for potential energy of an electric dipole in an external field. Means of that, in our expressions, work done by the external torque acting on electric dipole from angle theta 2 to theta 1 is equal to minus PE cos theta 2 minus cos theta 1. Okay, and this is the change in potential energy. Okay, or change in potential energy means of that U2 minus U1, that is equal to you write minus PE cos theta 2 minus PE cos theta 1, and this is assumed be U2 is equal to U1 is equal to U at fixed angle theta, that is equal to PE minus PE cos theta. This is our expression for choosable angles. But on the view of NCERT assumes the potential energy of an electric dipole is zero at a perpendicular angle. Means of that, if the electric dipole is perpendicular to the electric field intensity, the directions of electric field intensity is in the direction of this, and this is plus q and minus q, and here the potential energy of an electric dipole is zero, so all assumed, and here the potential energy of an electric dipole in an external field is zero. Okay, this is the zero, so we always choose the angle means of theta 1 is equal to 90 degree up to theta means of that here is potential energy 0, and here the potential energy, some potential energy, if we here 0, that is if we apply the torque on an this types in anti-clockwise direction, that is here the potential energy is in the negative, and out means of that out it is the potential energy of an electric dipole is in the positive. So we take assumption that is also it is this work is stored at a potential energy, and assumption to be that is theta 1 is equal to 90 degree and theta 2 is equal to theta, means of that potential energy U theta is equal to that is minus PE into cos theta cos theta 2 minus cos 90 degree. So u at angle theta is equal to minus PE cos theta, and value of cos 90 is 0, and you write this u theta is equal to minus PE cos theta. This is the formula for the potential energy of an electric dipole in an external field. Here, in on the view of ncert, we assume the potential energy of electric dipole in an uniform electric field is 0 if the electric dipole the directions of electric dipole is in the perpendicular to the electric field intense, so electric field direction of electric field, that is E. So always if we given the numericals, then in last term it add the potential energy of the electric dipole in an uniform electric field is 0 at a perpendicular to the directions of electric field. So we apply the formula. I take one question and solve this on the basis of electric potential energy. Okay, now I will write the questions. And I will take questions. What is the questions? You read a dipole with a magnitude of dipole moment 0.5. Sorry, 0.5 Newton meter is placed in an external uniform electric field of magnitude 10 Newton per Coulomb. P makes an angle of 60 degree with E. What is the potential energy of the dipole in the current configuration, provided that the potential energy is taken 0? This is the main points of these questions. That is the potential energy is taken 0 when the dipole is perpendicular to the applied field. Okay, this questions said that, and we take an uniform electric field. Okay, and this magnitude of electric field is 10 Newton per Coulomb. Okay, and take an electric dipole. Okay, this is plus q and minus q. Okay, and this is the uniform electric field. So, and we take electric dipole moment P, and this angle theta is equal to 60 degree. Okay, then what is the potential energy of electric dipole when the electric dipole, when potential energy is 0 when the electric dipole is in the perpendicular to the directions of electric field? Then in now just I had discussed that the potential energy of an electric dipole, if angle we free to choose pi by 2, that is we take the potential energy of electric dipole is 0, then the potential energy at angle theta is equal to minus PE cos theta. It is only valid for potential energy is taken 0 when dipole is perpendicular to the applied field. If it is not given, then we apply the and two angles is given, then that you apply change in potential energy, that is called to minus PE, that is cos theta 2 minus cos theta 1. This formula is applied if this is not given in the questions, and it is given in the question, we apply the formula, that is minus P cos theta. Okay, and this is the u theta at angle 60 degree. You apply all the numerical value and getting the result. This is the main term. Okay, this is P. What is the value of P? Means of that 0.5. Okay, 0.5. And what is the value of electric field? This is called 10 Newton per coulomb. Okay, multiply. Okay. And what is the value of cos 60 degree? What is the value of cos 60 degree? U at angle 60 degree. If the electric dipole is kept is perpendicular to the directions of electric field, then the potential energy is 0. Then U60 is equal to minus is equal to minus, okay, minus 0.5 into 10 into, what is the value of this? What is the value of this? This is the value of 1 by 2. Okay, 1 by 2, and we apply U60 is equal to minus 5, okay, 5.0 by 2, and we divide 5 by 2, we get minus 2.5 joule, and our option is D. This is the answer of these questions, minus 2.5 joule. And this types questions and various types of question carry in the examinations. You see my previous lectures, how to derive an expressions for potential energy of an electric dipole in an external field. Then you can easily solve question on the basis of this. If we learn the expressions, then you can easily solve the questions. And now my next topic is a simple topic, what is motion of a charged particle in uniform electric field. Then my topic is motion of charged particle in an electric field, uniform electric field. Now my topic is motion of charged particle in an uniform electric field. Okay, motion of charged particle in an uniform electric field. We assume that this charged particle is initially at rest. Okay, assumption be that assumption charge particle is initially at rest. Okay, and assume that a charge particle of charge q is placed. First of all, we take uniform electric field E. Okay, this is the uniform electric field E having same direction and same magnitude at it at each point. Okay, this is the electric field, and we take charge particle q, charge particle of having charge q is placed at a point a, and after some time it reaches point b, and the separations between these two charges is s. Okay, so first of all, what is the accelerations of the charge particle by the electric field? So first of all, if we know first of all acceleration of charged particle, acceleration of charged particles by the applying applying force, acceleration of charge particle by the applying force, apply the force, electric field, that is equal to, as we know that F is equal to QE. Okay, and here is given that if you take mass of a charge particle is m, that we can say F is equal to ma, that is ma, and this is called QE. Okay, and now acceleration of the charge particle is QE by m. This is the acceleration of charge particle in uniform electric field if the force QE applied by the electric field, then the acceleration of charge particle is QE by m. And now next one is second is a velocity of charge particle. Velocity of charge particle. We assume that a charge particle initially at rest, and after some time t it reaches point B. After some time it reaches point B. Then we apply the formula, equations of motions. This is the straight line, motion in a straight line. So we apply the formula V is equal to U plus AT. Okay. Now we know that initially the particle is at rest, so the initial velocity is 0 and acceleration is equal to QE by m. So we can say velocity of charged particles is equal to QE by m into t in terms of t. If the potential difference between these 2 points means of that the potential difference between A and B is consider del V. Okay, then we uh, escape the value of T. So we also know that V square is equal to U square plus 2A is. Now V is equal to V square is equal to U0 plus 2 and the value of A is equal to QE by M or into S. Okay, V square is equal to 2 QES divided by M, and I will explain in the topics capacitor. V is equal to ED. Okay, this is the change in potential difference, between 2 points, and this is the electric field, and D is the distance between these two particles. So we apply this formula, then 2 and Q ES. What is ES? ES. Here E is the electric field intensity, and also S is the distance between that two find. So we take del V as the place of ES is equal to del V. Del V is the potential difference between the point A and B by M. Then V is equal to under root of 2 Q del V by M. And now we can say the velocity of charged particle in uniform electric field is, first of all, in terms of time, then V is equal to QE by M into T, and in terms of potential difference between two charges and separation between them is S, then we apply the formula 2Q del V by M of under root. This is the formula for velocity of charged particle in an uniform electric field, and you learn this formula if we given the questions in terms of del V, Q and M, then we apply the formula and getting the velocity of charged particle. If initial velocity of charged particle is 0 in the questions. So now what is the momentum of that particles? Means of that, what is the momentum? Okay, momentum of the charged particle, first, second and third. Okay, momentum of the charged particle. Okay, as we know that momentum of the charged particles, usually formula for momentum is equal to P is equal to mv, and you know that P mass of charged particle is m, and velocity in terms of this, that is equal to QE by m into T. M से m cancel, that is equal to momentum is equal to QET, and in terms of del V, okay, then P is equal to m, okay, under root of 2Q del V by m. Now P is equal to m, okay, 2Q. If 1 by m is taken out of the root, then in root left 2m q del b. Okay, if we in these conditions we multiply by m in both numerator and denominator. Okay, m cancel, that is equal to p is equal to under root 2m q del b in terms of potential difference, and in terms of time qet. This is the momentum of charged particles. And various types of question solved by me if all the term explained, if all the terms explained. Okay, now momentum and what is the kinetic energy of the charged particles. Now kinetic energy of the charged particle. Fourth, kinetic energy of charged particle. That means you know that kinetic energy is equal to half mv square, and in terms of time half m, and on the place of v in terms of t is equal to qet by m. This is the value of whole square, and kinetic energy is equal to half into m into q square e square t square by m square. Cancel, that is equal to kinetic energy is equal to q square e square t square divided by 2m. This is our kinetic energy in terms of t. Now in terms of del v. Now in terms of del v. Now in terms of del v. Okay. Now in terms of del v. Kinetic energy is equal to half mv square. Okay. Now kinetic energy is equal to half m, and the place of v under root 2q, यहाँ q, this is the q, 2q del v by m of whole square. Okay, then kinetic energy is equal to half into 2q del v divided by m square से root cancel, 2 cancel, cancel, that is equal to kinetic energy is equal to q into delta v, and in terms of t, this is two formula for kinetic energy of the charged particle in uniform electric field. This is the topics of motion of charged particle in an uniform external field. If we if you will have learned this formula, then you can easily solve the numerical in the examinations on the question on the basis of motion of charged particle in an uniform electric field. Some selected questions I will explain. First two questions explain in this lecture, and next questions explain next lectures. So first question I will take. चलिए मैंने को I will solve these questions. Okay, first of all, I read the questions. An electron is released from rest. From rest. Point to be noted, from rest. That is initial velocity 0. Then we apply all the formula from the motion of a charged particle in an uniform electric field. Okay, so next term, in a uniform electric field, point to be noted, in a uniform electric field with a magnitude of 1.5 into 10 to the power 3 Newton per Coulomb, means of that given data electric field is equal to 1.5 into 10 to the power 3 Newton per Coulomb. Okay. Determine the acceleration of the electron due to electric field. And as you know that acceleration of charged particle is equal to QE by M. This is the very simple question. I will easy question. Next lecture I will take moderate questions and then after hard questions. It is a easy questions. Okay, it is only based on the formula. So we apply the all numerical value, that is Q is equal to 1.6 into 10 to the power minus 19. Okay, E is equal to 1.5 into 10 to the power 3 Newton per Coulomb divided by mass of the electron is 9.1 into 10 to the power minus 31. Okay. Now I will solve. That is, we multiply this term. 15 6 is 90. 0 carry 9. 15 1 is 15 on 9 or 24. That is 1 2 1 2. Okay. Divided by 9.1. Okay. Now 10 to the power 31 plus 3 minus 90. Okay. Now A is equal to 24 by 91. This is the cancel out. And now 10 to the power 3 means of that 10 to the power 34 minus 19, that is A is equal to 24 by 91 is equal to into 10 to the power 15. Okay. Now A is equal to 240 by 90 and divided 10 to the power 14. Okay. 91. This is cancel out 2.6. Okay. This is the 2.6 into 10 to the power minus 14 meter per second. Okay, this is our formula for the acceleration square. Okay, that's of all today. Next classes I will take moderate question on the basis of motion of charged particle. Motion of charged particle initially at rest is projected in uniform electric field. So thanks.